Hello again, Math 1 students. So today we're starting our geometry unit. So to get that going with our first lesson, I want you to think about for just maybe 10 seconds, what does the word midpoint mean? So what words do you see that make up the word midpoint? So I want you to think about that for 10 seconds. So to me, I see two words. I see mid, which is middle, and point, which is like in math, means a dot. So the middle dot, it's the middle dot of something. So what that looks like is we looked at this graph and we said find the midpoint. What's the middle point of AB? So there's a couple ways to do this. If you want to pause the video and try it out, be my guest. I think we can all get this one though. So I'm just going to count how many is it from A to B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half of 10 would be 1, 2, 3, 4, 5. That's the middle point of this segment AB. But what if it's not quite a straight line, like horizontal or vertical? All lines are straight, but what if it's slanted like this? What's the middle point? So take maybe 10 seconds, try to just maybe see the middle point, make a guess as to what the middle point is on this graph. So if you guessed this spot right here, you would be correct because we go over 2, up 1, over 2, up 1. That sort of slope is the same both times, so it's the middle. So it would be the point, that's 3, 3, comma, 2. Over 3, up 2. That would be the middle point of that graph. So let's move on. What is the midpoint of this graph? Well, take 10 seconds again and try to see if you can guess that midpoint there. So the point of this, how I get it, is there's no like exact dot where this midpoint is. It looks like it's right about there. And if we were to guess, we go back 1, 2, 3, 4, we go back 5, and up 1, 2, 3, 4, 5, maybe up 5.5, which is a pretty good guess here, but it's not always going to be that easy. So we need some sort of way to have a formula there. How can we calculate that exactly? So we have this thing called the midpoint formula. So I want you to take some formal notes on this in your toolkit. So what the midpoint formula is if you have 2 points, x1, y1, and x2, y2, use the formula to find the midpoint. So it's important to know that x1, y1 just means the first x value and the first y value of like the first point. x2, y2 means the x value of the second point and the y value of the second point. So that's all that means. And then we have this midpoint formula up here. So middle of two numbers is we're going to average them, kind of like we did with our median. If you had two numbers that the median was between them, you would add them together and divide by 2. And then you also add the y values together and divide by 2. So you're taking the first x value and the second x value, adding them together and dividing by 2. And then the first y value and the second y value, adding them together and dividing by 2. So how we would use that is if we wanted to find the midpoint of 4, 8, and negative 3, 2. So the first thing I'm going to do is I'm going to graph over 4, up 8. That's 1 point right there. And the other is back 3, up 2. So I'm going to connect these. And we want to find what is the midpoint there. So I like to label this x1, y1, x2, y2, just so I can keep it straight in my head. And we're going to find the midpoint. So it's first thing we're going to do is add the two x values, 4 plus negative 3, and then divide them by 2 to find the middle of the x's. And then we're going to find the middle of the y's, 8 plus 2 divided by 2. And we're just following our algebra here. So 4 plus negative 3 becomes 1 divided by 2. And 8 plus 2 is 10 divided by 2. And you could leave it as 1/2. I'm just going to make it a decimal. And 10 divided by 2 is 5. So if we're going to graph that, we go over 1/2, up 5. So you can see my line was pretty close to that midpoint, but we calculated it algebraically. I'm going to have you try to find this midpoint algebraically. Now you can probably look and guess what it is, but calculating it algebraically is a good way of checking your answer. So our 2 points here, our b is over 4, up 5, and a is 1, 1. So pause the video and try to calculate that algebraically, and then when we're ready, unpause it. So here's what I got for my midpoint. So I got 2.5 over, 3 up. And that looks like it's the midpoint there. Now I heard someone ask through the camera, does it matter which point is the first one and which one's the second? No, it doesn't. I said this was first and this was second. You could have flipped those around. It doesn't matter. You just, order won't matter when you're adding them together. So either one would work. So let's move on. I want you to try to find the midpoint of each set of points. So pause the video and try to find these two midpoints, and then unpause when you're ready to check with me. All right, here's my two answers. I got 3, 9, and negative 1, comma, negative 2.5. So check your answers, and if you made a mistake, try to find that mistake. It's usually with negatives and positives and adding those together. But if you got those same two answers, you're ready to move on. So next up, a sort of extension for this is that C is the midpoint of AB. Find the location of B. So we don't know where B is. So how this works is to get from A to C, we know C is the midpoint. So AB is going to be somewhere over in this area. So take maybe 20 seconds, pause the video, and try to find out where would that point B be located. What is the coordinates of it? So you have your answer, and I'm going to show you how I would do it. There's a bunch of different ways to do this. I'm just going to show you mine. So to get from A to C, we go down 1, over 1, 2, 3, 4, 5, 6. So from C, I'm going to go down 1, and over 1, 2, 3, 4, 5, 6. So that's where B would be, and it's over 4, and it looks like up 5 units. So if you know the midpoint and one endpoint, you can find the other endpoint. So next up, we can find the midpoint, and we're also going to find the length of AB. So you might remember this from last semester, but if we want to find the length of something, there's a special triangle we always draw. We're going to turn it into a right triangle. And then we're going to find these side lengths. So this is 1, 2, 3. 1, 2, 3, 4. So how can we find the longest side of that right triangle? Well, it's something called the Pythagorean theorem. Now I'm going to abbreviate it. But if you remember the Pythagorean theorem, it's a squared plus b squared equals c squared. So here we have our two shorter sides are always a and b, and c is the hypotenuse. So we're going to have 3 squared plus 4 squared equals c squared. So 3 squared does not mean 3 times 2. 3 times itself is 9. 4 squared is 4 times itself is 16. 25 equals c squared. What number times itself is 25? If you said 5, you are correct. Another way to show that work is it's called square rooting both sides. It undoes the squared. So we got that to be a length of 5. All right, I want you to try and find the length of AB here. So remembering our first step is to turn it into a right triangle. So pause the video and try to find that length and unpause when you're ready. All right, so when you get to this step, is there a number times itself that's exactly 20? No. So we're going to have to square root both sides, and we are just going to leave it as the square root of 20. You don't need to do anything more than that, since there's no exact number. In the last one, it was exactly 5, but here we don't know it, so you just leave it as square root of 20. The last part of this midpoint work is we're going to solve for x in each diagram. So if you can see, here we have 4x minus 1, 3x plus 3, and there's these 2 tick marks right there. That means this line is the same length as this line. What's a word for the same in math? Equal. So we're going to write 4x minus 1 equals 3x plus 3. And we can solve this equation now. If we have x's on both sides, we want to get rid of the x's on one side. So we're going to subtract 3x here, subtract 3x here. 4 x's minus 3 of them leaves you with just 1x. X minus 1 equals 3. And then we're going to add 1 to get rid of the minus 1. So x equals 4. So on our second one, to set up the equation, we know this is 5x minus 3, 11 minus 2x. So our equation here would be 5x minus 3, and this tells us they're equals 11 minus 2x. So pause the video and try to solve for x in this diagram. Unpause when you're ready. All right, so here's my work. The first thing I did, the first step, most important one, is I added 2x to both sides, because negative 2x plus 2x gets rid of it. And now we just have x on one side. So for the last thing you're going to do today, I want you to try to solve for x in the diagram below. Thanks for joining us.